Right, listen up, petrol heads and gear heads. Today we're talking about a real game changer, the internal combustion engine, or ICE for short. This isn't some boring science lesson. This is about the heart of millions of machines that make our world tick. Imagine a world without cars, bikes, planes, or even power tools. Sounds dreadful, doesn't it? That's what life would be like without the ingenious invention that takes a simple cocktail of fuel and air and turns it into raw mechanical power. From the moment someone figured out how to make controlled explosions move stuff, everything changed. Suddenly, we weren't limited by horses, wind or steam. We had portable power, ready to propel us into the future. And what a future it's been. The ice has taken us further and faster than we ever thought possible. It's the driving force behind our industries, our transportation, and let's be honest, a good chunk of our fun. So buckle up as we delve into the fascinating world of the internal combustion engine. The story of the ICE isn't just about nuts, bolts and explosions. It's a story of brilliant minds, daring experiments and a relentless pursuit of progress. We're talking about pioneers like Nicholas Otto, the genius who cracked the code of the four-stroke engine, the granddaddy of most engines we use today. Then there's Rudolf Diesel, the man who said, "Forget spark plugs, let's make fuel explode with pure compression." And he did, changing the world of heavy machinery and trucks forever. But the story goes back even further. Imagine tinkering in sheds and workshops, the air thick with smoke and the smell of oil. Early inventors were obsessed with harnessing the power of fire. They knew that if they could control it, they could control the future, and control it they did. From clunky, steam-powered contraptions to the refined engines we see today, the journey has been a long and exciting one. It's a testament to human ingenuity and our insatiable desire to push the boundaries of what's possible. Now, let's get down to the nitty-gritty. How does this whole combustion thing actually work? It's a fascinating process that powers so many of the machines we rely on every day. In the simplest terms, it's all about a controlled explosion, but there's so much more to it than just a bang. Take a bit of fuel, mix it with the right amount of air, and boom, you've got energy. This mixture is crucial because the right balance ensures efficient combustion. Think of it like a campfire. You need fuel, wood, air, oxygen, and a spark to get things going. Without any one of these elements, the fire won't start or sustain. In an engine, the fuel is usually petrol or diesel, and instead of a campfire, the explosion happens in a confined space, the engine cylinder. This containment is what makes the explosion useful. This is where the real magic happens. The explosion pushes a piston, which then turns a crankshaft, and voila, you've got power to the wheels. This conversion of energy is what propels your vehicle forward. This entire process happens in a beautifully choreographed sequence called the four-stroke cycle. Intake, compression, combustion, and exhaust. Each stroke plays a vital role in ensuring the engine runs smoothly. It's a bit like a dance, really. Fuel and air come waltzing in, get squeezed tight, ignite in a fiery embrace, and then the spent gases are politely shown the door. This dance repeats over and over, creating a rhythm that powers the engine. This cycle repeats thousands of times every minute, providing the driving force behind your car, motorcycle, or lawnmower. The speed and precision of this process are truly remarkable. Who knew explosions could be so elegant? The science of combustion is a perfect blend of chemistry and engineering, creating a symphony of power and efficiency. Now let's lift the bonnet and peek inside this mechanical marvel. The internal combustion engine, or ICE, is a masterpiece of engineering that has powered our vehicles for over a century. Don't worry, you don't need to be a mechanic to appreciate the beauty of a well-crafted engine. Just take a moment to admire the intricate design and precision of each component. At the heart of it all is the cylinder. This cylindrical chamber is where the magic happens, converting fuel into motion. This is where the action happens, where fuel meets its fiery destiny. The fuel is injected into the cylinder, mixing with air to create a combustible mixture. Inside the cylinder, a piston moves up and down like a runner on a track, driven by the force of the combustion. This up and down motion is the fundamental movement that powers the engine. Connecting the piston to the crankshaft is the connecting rod, transforming the piston's linear motion into the crankshaft's rotation. This rotation is what ultimately turns the wheels of the car. Think of it as the intermediary, translating one form of movement into another. Without this crucial component, the engine's power couldn't be harnessed effectively. But it's not a one-man show. The engine is a complex system where every part plays a vital role. The valves act like bouncers, controlling the flow of fuel and air into the cylinder and letting the exhaust gases escape at just the right moment. They ensure that the engine breathes properly, maintaining efficiency and performance. And of course, you need spark plugs to ignite the party, creating the controlled explosion that starts the whole cycle. These tiny but mighty components are essential for the engine's operation. All these components work in perfect harmony like a well-oiled machine, literally, to deliver the power that drives our world. Each part must function flawlessly to ensure the engine runs smoothly and efficiently. It's a symphony of engineering, a testament to human ingenuity and our ability to create something truly remarkable. The internal combustion engine is more than just a machine. It's a marvel of modern technology that has revolutionized transportation and shaped our world. Now let's dive into the different types of internal combustion engines, or ICEs. There are quite a few, so we'll cover the most common ones. Internal combustion engines are the heart of many vehicles and machines, converting fuel into mechanical energy. First up, we have the spark ignition engine, which is probably the type you're most familiar with. These engines are widely used in cars, motorcycles, and small machinery. These engines use a spark plug to ignite the air-fuel mixture. The spark plug creates a small explosion that drives the piston, producing power. Next, we have compression ignition engines, commonly known as diesel engines. These are often found in trucks, buses, and heavy machinery. Instead of a spark plug, these engines rely on the heat of compressed air to ignite the fuel. This process makes diesel engines more efficient, especially for long-haul applications. Diesel engines are known for their efficiency and durability. They can handle heavy loads and are built to last, making them ideal for industrial use. Then there's the two-stroke engine, which completes a power cycle with just 2 strokes of the piston. This type of engine is simpler and lighter than its 4-stroke counterpart. These are often found in smaller applications like motorcycles and chainsaws because of their simplicity and lightweight design. They are easy to maintain and provide quick bursts of power. Finally, we have the 4-stroke engine, which is the most common type used in cars. This engine is known for its efficiency and smooth operation. It completes a power cycle in 4 strokes: intake, compression, power, and exhaust. Each stroke plays a crucial role in the engine's performance and efficiency. This type of engine is known for its balance of power and efficiency. It's designed to provide a smooth and reliable performance, making it ideal for everyday vehicles. So, those are the main types of internal combustion engines. Each type has its own unique design and function, tailored to specific needs and applications. Each has its own unique characteristics and applications, making the world of ICEs quite diverse and fascinating. Whether it's for speed, power, or efficiency, there's an ICE designed to meet those demands. All right, let's dive into the mechanics of internal combustion engines. At its core, an ICE converts the chemical energy in fuel into mechanical energy, which then powers a vehicle. This process involves 4 main stages: intake, compression, power, and exhaust. Each stage plays a crucial role in ensuring the engine runs smoothly and efficiently. So, how does it all come together? Well, it starts with the intake of air and fuel, followed by compression, ignition, and finally the expulsion of exhaust gases. It's a fascinating sequence that has revolutionized transportation as we know it. Now, let's explore the various applications of internal combustion engines. These engines are not just limited to cars and motorcycles. They power a wide range of machinery, from lawnmowers to boats and even airplanes. Their versatility and reliability make them indispensable in many sectors, including agriculture, construction, and transportation. Whether it's a small garden tool or a massive industrial machine, ICEs have proven to be incredibly adaptable and efficient. So what makes internal combustion engines so advantageous? For starters, they offer a high power-to-weight ratio, making them ideal for vehicles that need to be both powerful and lightweight. They are also relatively easy to refuel, with a well-established infrastructure for gasoline and diesel. Additionally, ICEs have a long history of development, which means they are highly optimized for performance and efficiency. These benefits have made them the go-to choice for many applications over the years. However, it's not all smooth sailing for internal combustion engines. They face significant challenges, particularly in terms of environmental impact. Emissions from ICEs contribute to air pollution and climate change, prompting a shift towards more sustainable alternatives. The future of ICEs will likely involve advancements in technology to reduce emissions and improve efficiency. Hybrid systems, biofuels, and even hydrogen-powered engines are being explored as potential solutions. While the road ahead is uncertain, one thing is clear: the internal combustion engine will continue to evolve in response to the demands of our changing world.